B.5, questions of quiz 1, part 1, 1 through 5. I look at the total number of minutes for part B at this point. I noticed that we still have about 20 minutes. So I feel I can use this number of minutes to explain all the questions in quiz 1. So that's a perfect fit. All right, so let's do the part 1 first. The first 5 questions. Question 1, what is the name of the program that beat the human world champion of the Go game the first time as an AI milestone? If you follow the video clearly, because there is a story behind it. So you can easily get the answer is third one, AlphaGo. Okay, yeah. So that long story, I do not repeat here. Yeah, do not get confused because the master is the newer version, the next version after AlphaGo, improved version. But we do not use master, that name, yeah, because the time different. The time period is different. Yeah. All right. Yeah. So that's the first question. Second question. There is some question about this question. So first, I want to tell you, we skip this question. Skip it. Yeah. So do not count it. If you miss it, I will give you 4 points back. Yeah. In my answer, I said this is the truth. I said this, yes, is the correct one. So we will do this. If you answer yes, what do? No action. You do not need to do anything because you got 4 points from this answer. So you are fine. If you answer no, send me a message. To get 4 points back. Okay, yeah. Do this. Don't forget to do this. You can get 4 points back. Okay, all right. Let me explain the reason I want to skip it. The main reason is the meaning of the question is not clear. Yeah. So when I create a question, I had something in my mind, but later, after one student asked me a question, so I thought about it another time, so I felt the question I gave you not give you precise meaning. Yeah. So let me explain a little bit. All right. When we evaluate a particular polynomial, is it possible that the number of additions could be greater than the number of multiplications? Here you can see, here we compare two numbers. First, the number of additions and the number of multiplications. But under what situation? I didn't describe the specific situation. Under what base? That is important. Yeah. Because when I designed this question in my mind, I thought in this way. So I do not specify the situation. You can use any way you want to do. In other words, you can find a way that uses minimum number of additions, and you can also find a way minimum number of multiplications. Then you compare, right? So I think in that way. Yeah. But in my question, I didn't give you that meaning. I didn't give you that meaning, right? So the minimum number of addition, the minimum number of multiplication, I didn't say that. So it's not fair to, to make you guess that meaning. So it's not fair. Okay? So for that reason, I think the best way for this question, we just skip it. Yeah. So it's my fault. I should describe the, situation clearly here. Yeah. Yeah. Otherwise, it's not a good question. Yeah. All right. So we skip it. Yeah. Don't forget to do these things. All right. Yeah. The first, yes, just, don't do anything. Yeah. If you answer no, yeah, just send me a message. So I will change. I will go to your grades part and add 4 points to your quiz 1 score. Yeah. All right. So let's go to the next one. Number 3. Is the execution time of a program a stable measure for the performance? Not a stable. No. Yeah. In my video, I explained that. In my video, I said someone can use a supercomputer, right? Very powerful supercomputer. Another person can use a 10-year-old computer. How can you compare using execution time, right? So it's not a fair measure or stable measure, right? Yeah. So that's the background. Yeah. All right. So number 3. Number 4, given a polynomial with 10 items, we use the Horner's rule to evaluate. Here I specify. Yeah. So that's the way we do the evaluation. So that is clear. Right? I say Horner's rule. In question number 2, I didn't say Horner's rule, right? I didn't say Horner's rule. So that's why the question description is not very clear. Yeah. Here it is quite clear. We use Horner's rule to evaluate how many multiplications do we need. Answer is 9. Answer is 9. Okay? So you can go back to look at the formula, the parentheses, nested parentheses. From 0, we have n plus 1 coefficients, right? 0, A0, A1, A2, through A9, or n minus 1. Yeah, right? So you can see the number of multiplications is 1 fewer than the number of total terms. Because for the first term, we do not associate multiplication with it. Other than the first term, for each term, we associate a multiplication with it. So you reduce the term number by 1. So you get the number of multiplications. 9. Okay? 9. Yeah. I saw some students, give me different numbers. So you need to think about it. So go back to look at the factorization formula. Common factor. Remember, we did common factor factorization formula. Look at that one. Okay? So then you carefully do the counting. Okay? Oh, yeah. Right. Yeah. Anyway, yeah. Number of terms. Yeah. Yeah. 1 less than the total number of terms. Yeah. All right. Yeah. So let's go to the next question. Last question for this part. What is the minimum number of multiplications that we need to evaluate x to the 51? Many students give me answer 8. Actually, answer 7. Why? There is one difference. Because this one, the number I use here, 51, do you know 51 equals 3 times 17? 3 times 17, yeah. In one video, I gave you 2 techniques. The first one is called repeated squaring. the second technique, repeated cubing. Here we need to use this one. If you use the repeated squaring, you get answer 8. Repeated cubing, you can get answer 7. Yeah, so let's try a little bit. Very easy. Yeah. So x to the 17 multiply x to the 17th multiply x to the 17th. All right? Yeah. So you can see 2 multiplications, right? But now, how many multiplications do we need to get x to the 17th? All right. 1 plus 16th, right? 1 plus x to the 16th. But x to the 16th, x times x. Repeated squaring, right? Yeah. Repeated squaring. Okay? All right. So squaring, that's 1 multiplication. All right? Yeah. Repeated squaring. 2 times 2 times 2. 8th, right? 8th. All right? Yeah. 16th, another one. 2 times x. That's 16th. Okay? So 1 multiplication, 1 multiplication, 1 multiplication, 1 multiplication, 1 multiplication, right? So total 5 multiplication. Yeah. 5 plus here 2, right? Here 2. So 5, finally, yeah. 5 plus 2 equals 7. Yeah. Here you can see the repeated cubing has its advantage for this particular special case. For some other cases, repeated squaring may have an advantage. Okay? And if you try to do number very big, x to the nth, excuse me, you need to use both. You need to use repeated squaring. Yeah, here we use repeated squaring, right? Then repeated cubing, both. All right, so that's the part 1. So let's finish this one first.